Hello guys, welcome you all for this end-to-end session on AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. So hope you guys are enjoying a lot. So we are enjoying and we are learning a lot. Each and every day we are learning new thing and we are just like enabling our knowledge. Like each and every day we are just learning new things, guys. So hope the same thing for you guys. So yeah, as always, before coming to this session, make sure you guys watch all the previous session videos so that you guys can have a better understanding of what we're gonna talk. So today is gonna be one more clustering technique, that is DBSCAN. Guys, for the past three sessions we have looked into what is hierarchical clustering, a black box of it, and then we have seen the coding part. So make sure if you guys doesn't watch those videos, watch those videos, because like I will say, you need to have a clear understanding of how a clustering works, what are the different types we have, so why we are going for DBSCAN. So this is what the flow that I need. So if you guys doesn't watch the previous session videos, make sure that you guys watch all the previous session videos so that we can have a proper understanding of what we are saying. Okay. So guys, yeah, without wasting any time, let us jump into today's session. So today's session is all about DBSCAN in data science, guys. It's a simple session. Okay, we're gonna see the DBSCAN theory concept and black box of it. Okay, yeah. So first, DBSCAN in data science. DBSCAN is a density-based clustering algorithm that is widely used in data science for identifying clusters of varying shapes and size. This presentation explores the key concepts of DBSCAN, its strengths and weakness, and its application in the real-world scenarios. Okay, so guys, I will put it in a simple manner. We have discussed about two different clustering techniques. Okay, K-means is purely for the data that you can cluster in a spherical manner, circle. Whereas hierarchical clustering, you can divide or cluster the dataset in a manner of tree. What if we have different shapes? That's the reason we are having something called as DBSCAN. It is a density-based clustering algorithm. The shape can be anything, size can be anything. Here, this algorithm will work best. Okay, so I will say it's one of the updated algorithm from k-means hierarchical clustering. So we are having an updated algorithm which is called as DBSCAN. So it is one of the clustering technique and it is also unsupervised. Okay, so hope you guys able to start to understand this DBSCAN. Let's move one by one so that you can have a clear understanding of what is black box behind it, what is the theory concept behind it. Okay, so hope you guys can understand. Yes sir, over to you.
Yeah, guys, DBSCAN uh, in data science or AIML. So DBSCAN is density-based clustering algorithm, okay, that is widely used in data science for identifying clusters of varying shapes, size, okay. So DBSCAN is stringent and it has strengths and weaknesses. Its strengths and weaknesses and its application in real world. That's what we are going to learn in simple terms. So what are the strengths, what are the weaknesses, and the applications in the real world? Okay, so this is a clustering algorithm, okay, density based clustering algorithm, which is widely used in data science and AIML. So we'll learn deeply in other sessions about it. So let's start and let's go to the other section. But if you have come to this session, so first watch 5 to 10 times, which is the median for learning some skill deeply, the concept first, what and why, and then application of how. So these are three things. With simplicity, have a long-term objective function, long-term goal for your career, not for career only, guys, for curiosity, for knowing this technology deeply. Then, um, then once you understand that it is written in Gita Ji that you do your karma, don't worry about the fruits. If we apply this particular verse in real life, okay, so our life is heaven, because I'm saying only this, because whatever karma we do, without expecting the fruit. So Krishnji says to Arjuna that don't worry about the fruits, just do your karma with long-term objective function, long-term vision. So once you do that, so once you learn, not for salary, not for position, not for this, knowing, curiosity, and serving humanity. That's the core objective you need to have. You will become world's best 1% talent, I must say. Okay, so learn with persistency, consistency, perseverance, and patience deeply at a meta level, all these concepts, so you become world class. Okay, so let's move to the other section.
Yeah, sure, sir. So, moving on, let's see what is DBSCAN. Okay, let us discuss what is DBSCAN. Density based clustering. DBSCAN groups the data points based on their density in space. It identifies clusters of any shape, unlike algorithms like k-means. Yeah, this is what I have explained, right? So, based on the, let us consider if we are having a number of data points is 5, then it is considered as a cluster. That's it. It is not considering it should be a spherical shape or it should be some shape of tree like that. No, there is some condition like minimum number of sample. If we put as 10, whenever we get a count of 10, it becomes a cluster. That's it. Okay. Identifying outliers, yeah. DBSCAN effectively identifies outlier data points that don't belong to any of the clusters. This is helpful for anomaly detection, guys. I hope like DBSCAN is the only algorithm. I hope no. DBSCAN is the only one algorithm which can helps us to find the outlier in a very easier fashion. Okay, because when we mention a minimum number of samples to become a cluster, right? If 10 it is, if there is 10 data points which is closer to each other, they become a cluster. So like that it becomes a cluster for entire data set. Consider you are having a 110 samples. 100 samples becomes somehow clusters based on the minimum number of neighborhoods or minimum number of samples to become the cluster. 10 samples are outside of every cluster. So you can consider those 10 samples as the outlier. So it's a simple way of finding the outlier. Okay. Hope you guys can able to understand. Okay. Next. Scalability. DBSCAN is relatively scalable, meaning it can handle a large data set with reasonable computational time. It performs well on high dimensional data. Yeah, sure. Simple technique, guys. So that's the reason it is very scalable. You can have any number of huge data set. Okay, I will say the record can be 1 lakh, 2 lakh, anything, because it has a simple strategy. You're gonna pick the minimum number of samples to become a cluster. If you're gonna tell it is 10, then wherever the 10 data points is closer to each other, they become a cluster. That's it. Okay, it doesn't worry about it should be a spherical shape. We should need to go for a hierarchical kind of thing. I need a tree to be splitted from root to leaf. No, nothing, not like that. That's the reason it is very scalable. Next, noise detection. Yeah, DBSCAN identifies noisy points, which are the data points that are not part of any clusters. This can be helpful in data cleaning and pre-processing. Yeah, it is similar to anomaly detection, outlier detection. So, noise and outliers are major thing, guys. So your data set should not contain any outliers or noise. So whenever you detect an outlier, it can be detected by using DBSCAN. You can apply to some real world application such as anomaly detection. When it is noise, you can remove it to process some data cleaning and pre-processing. I will say once you have a data set, use DBSCAN to remove the outliers and noisy data. Then have the data set, clean the data set, then apply any algorithm that you need. Use this algorithm as a pre-processing step. Okay, it's perfect, right? It sounds right. It sounds great, right? Because since it removes the outlier, you're gonna have a pure data set. Since it's gonna remove some data points which are noise, it's gonna have a pure data set. So have a original data set, apply this DBSCAN algorithm, do the pre-processing and remove the outliers and as well as noise, have a pure data and apply to the algorithm, whichever algorithm you need. Okay, so hope you guys can able to understand, right? So it's a simple thing. Okay, this DBSCAN can be used as a pre-processing step. That's the reason I'm just mentioning. You can use this as a first step whenever you get a data. Once the data is clean, you can apply any kind of algorithm. Okay, so yeah, sir, over to you.
Yes, so what is DB scan? Okay, density based clustering DBSCAN groups data points based on their density. See, every concept has its central idea, guys. Whenever you study any concept, there is a central idea and an objective function of that particular concept. So here, similarly, in DBSCAN, it groups data based on their density in the space. That is the central idea of DBSCAN, and it can identify clusters of any shape like algorithms like k-means, unlike algorithms like k-means. Okay, so that is the first element. What is DBSCAN? Okay, then second, identifying outliers. It is very good. It is very effective, I'll say, identifying outliers, data points that doesn't belong to any cluster, guys. Remember this stress, any cluster, not you'll say this some data belongs to this cluster, not that cluster, any cluster, whatever clusters are there. So this is useful for anomaly detection. So third is scalability. Scalability, DBSCAN is relatively scalable. It will handle large data sets into reasonable computational time. It performs well on high dimensional data. So scalability is there. That is the another, I'll say, element. What is DBSCAN? Then noise detection. It identifies noise points, which are data points that are not part of any cluster. Again, so outlier and noise points are like it's noise. It's not having any information and which is not relevant for our problem solving or performance, or it is not related to our objective function. This can be helpful in data cleaning and pre-processing, and this helps. So DBSCAN helps us in data cleaning and pre-processing. Okay, so remember all these four elements. What is DBSCAN? Let's move to the other section.
Yeah, sure, sir. So moving on, let's see what we are having next. Okay, key concepts. Let us see what are the key concepts we are having. Density, epsilon, minimum points, guys. These are the parameters you guys need to understand before moving for the coding session. So we are learning a black box here, right? Let us understand this. Density. Density refers to consideration, uh, concentration of data points in a given region. DBSCAN uses density to define the clusters. Okay, like consider you are having a huge number of data points in one place, then it is called as a density. Then it becomes a cluster. That is what density. I hope you guys can able to understand, right? Density refers to concentration of data points in a given region. DBSCAN uses density to define clusters. Simply understand, DBSCAN defines the clusters based on density. Okay, it's perfect, right? Guys, if you guys watched all our videos related to clusters, then you guys able to understand. Okay, K means we have used elbow method. Hierarchical clustering, we are use something called as a dendrogram. For DBSCAN, we are using something called as a density to define the clusters. Okay, hope you guys have understand. Okay, next, epsilon. Epsilon defines the radius of neighborhood around a data point. Data point within this radius are considered neighbors. That's it. Epsilon considered as a radius. Okay, whatever the value inside the radius, that is called as the single cluster. Those data points belongs to a single cluster. Okay, so epsilon means radius. Whatever the data points inside that radius considered to be only one cluster. Then minimum points, that is min PDS, is the minimum number of data points required in a neighborhood to consider a data point as a core point. Okay, consider you are having a data point inside the radius, and in order to say it as a core point, it should have the neighboring data points to the minimum points. That's it. Okay, hope you guys can understand. Density means this defines the clusters in DBSCAN. Epsilon means it's the radius. Whatever the data points inside the data is considered to be only single cluster. Then we are having something called as min point. So when the data point is considered as the core point, when it has the minimum number of neighbors around it based on the min point. Okay, if we are saying 5 data points should be there around a point in order to consider it as the core point, then 5 is the minimum point. That's it. Hope you guys can able to understand. These are the key concepts, guys. And I will again say DBSCAN is going to be only 2 lines of code. You need to load the DBSCAN, you need to apply the DBSCAN. Okay, but these are the black box you guys need to understand. Okay, so yeah, sir, over to you.
So key concepts in density, okay, epsilon and minimum points, which is like key concept points for this. So density, epsilon, and you have minimum points, which is MINPTS short form. Okay. So for epsilon, there's small e in bracket. So density refers to the concentration of data points in given region. So you can see a picture here. So where is the, if I'll say where is the most of the density, that is in the center, which we can call it centroid, okay? Center point, we can call it nucleus, okay? The central point. So that's what is called density, the concentration of data point. There's law given region. There's a lot of data points in the particular region. That's called density. So DBSCAN uses density to identify clusters. So it will do one thing. More density, it will have a cluster. Lesser density, have a cluster. More lesser than that, lesser than that. Suppose you have a jar. You have 4 type of pebbles. What you will do? You will segregate into different elements, even if you are not. But then you you will see they will have the bigger will be with bigger, their edges will be with the bigger, the smaller will be the medium, and they will have different class. So you can see in soil layers also that also has different segmentation, right? So this is how density you can see in stars also. A lot of stars, when sky is very clear, you can see they're dense stars. They're lesser, medium, like medium density. Then there is spread, right? Same way you can visualize it. The epsilon is it it defines the radius of the neighborhood around a data point. Okay, data points within the radius are considered neighbors. So there is always a radius. Okay, so like even if you study sky astronomy, you'll see. So you will see we have segmented north, south, east, west, this galaxy, that galaxy, this star, that star. So similar because we want to understand them. So each radius will have its information. So we can focus on that properly. Algorithm will focus on it once we have done proper segmentation, classification. So that is why it is important. The minimum points is um, is the minimum number of data points required in a neighborhood to consider data point as a core point. I'll give example. Like we have elections, so we have minimum voters for a state assembly, and uh, we have more voters for the Lok Sabha election when we have to choose uh, the the central government. The region is big. You will have uh, three constituencies in one, right? So that is what the minimum point is, the minimum number of data points required in a neighborhood to consider data point as a core point. right? So you can relate it with that, or you can have other examples to visualize or relate it so that you understand. So let's move to the other section.
Yeah, sure, sir. Yeah, moving on, let's see. DB scan in pre-processing. Yeah, this is what we have mentioned in the previous slide itself. Okay, so DB scan in pre-processing, that is data pre-processing. Outlier removal. DB scan can identify and remove the outlier that can skew the results of other machine learning algorithm. Yeah, guys, as I mentioned, right, because it gonna create the clusters in the unstructured format. That's the reason whatever the data point that doesn't belong to any of the cluster becomes the outlier, and you can find the outlier and able to remove it. Okay, then cluster analysis. DBSCAN can be used to group similar data points together, which can simplify analysis and improve the performance of subsequent algorithms. Yeah, you can use it for clustering analysis. You can, once you make the data clean and removal of noise and outlier, you can have this DBSCAN as base, and you can apply any other algorithm on top of it, any clustering algorithm on top of it, and you can analyze it. Next, feature engineering. DBSCAN can be used to create a new feature based on the cluster membership. For example, a new feature represents the cluster to which a data point belongs can be created. Okay, so I will put it in a simple manner, guys. I think this is going to be like 20th or 25th time we are explaining feature engineering. Whenever you are able to create a new feature from the existing feature, then it is called as a feature engineering. Okay, this DB scan allows us to create a feature engineering columns. Okay, so yeah, guys, this is what all about DB scan in data pre-processing. Hope you guys have already understand by using the previous slide itself, but like this is an elaboration of it. So how DB scan useful for data pre-processing? It used to outlier removal, cluster analysis, and feature engineering. Hope you guys can able to understand. Okay, so yeah, sir, over to you.
Yes, guys, understand again, DB scan in data processing, which we have already studied, that it will help us in data cleaning and pre-processing, data pre-processing. So here it helps with these three aspects and characteristics. One is outlier removal. That is very important for pre-processing, guys. So DBSCAN can identify and remove outliers that can skew the results of other machine learning What is skew, guys? Can you write in the comment section? Skewness can be positive skew or it can be negative skew. I'll give you idea. Just write in the comment section. So cluster analysis. DBSCAN can be used to group similar data points together, okay, which can simplify analysis, improve the performance of subsequent algorithm. These are the very important aspects of clustering, guys, because it has to simplify analysis, it has to improve the performance. Okay, then feature engineering, it can be used to create new features based on cluster members, which is like if you see machine learning, whether it is supervised or unsupervised, actually we need to create new features. And with when you create new features with feature engineering, performance of the model increases and it will find hidden patterns, which would be hidden insights, which will help us to make better decisions for uncertainty. Ultimately, guys, we are using AI, ML, data science, all these technologies to predict the uncertainty for the future so that we make right decisions. That's it. Nothing more than that. With data, and which is driven by data insights and backed by data. For example, a new feature represents the cluster to which data point belongs can be created, like which data new feature representing the cluster to which a data point belongs can be created. So this is how outlier removal DBSCAN helps in data pre-processing, creating cluster analysis, feature engineering. Okay, so we hope that we have gone through these concepts number of times, But do reinforced learning 5 to 10 times, understand deeply. I'll say more than 10 times. The more you do reinforced learning, like children's, they learn by reinforced learning, okay? They never give up and they become masters. So, same way, we have to become, for learning, we have to become children, shameless for learning, I'll say. Don't have any shame for learning, education, even if you make mistakes, no problem. Try, do reinforce, and don't take it to heart. Just keep learning deeply, okay? And you will become world class. Let's move to the other section.
Yeah, guys. So yeah, learn a lot. So yeah, guys. So this is all about the today's session we are having. We will pass here and we will continue this theoretical and a black box of DBSCAN in the next session. So yeah, guys. Today we have introduced your DBSCAN, which is far better than any other model that we are having. Okay, because it is not limited to a shape, or it is not limited to some kind of structures. Okay, so DBSCAN is unique and it has lots of advantages when compared to other algorithms. So yeah, guys, this is all about today's session. Make sure you guys watch the entire session, and then if you guys have any doubt, just ping in the comments. We will take up and we will solve your doubts. Okay, because like we are here to help you. Okay, so yeah, guys. So as always, like I will meet you all in the next session. Until then, bye, guys. Take care.